Okay, question 2007, right? We told there's a ladder against the wall, A on the ground, B wall. The ground is rough, but the wall is smooth. Now it's important that we have the reactions, okay? Because when it is in contact with the ground, there's a normal reaction, okay? So maybe we'll call that R there, and the reaction is perpendicular to the surface, the ground, and there's also going to be a reaction here at B, okay? And that reaction is always perpendicular, okay? So when something's in contact with the surface, you have a normal reaction, okay? Which is perpendicular to the surface. We call this one R, maybe we'll call that one N. And we told that this ladder is it's got a weight of 90, I believe, 90 newtons, okay? So you can put that in halfway, okay, between the ladder. And then it says, if you read on, it says that there's a force, okay? There's a force pushing this ladder horizontally, okay? And this force is called P, all right? At this point here, which is half a meter from A, okay? Half a meter from A, and of course that would be another half a meter, and then you've got 1 meter here. All right, so we're going to draw all the forces in here, and I think I've got most of them so far. But what it does say then, of course, is that this ladder, because it's been pushed here, is that it's on the point of moving towards the wall. So actually A is on the point of moving. So the ladder is going to sort of slide up the wall like that. Okay, it's going to be pushing up the wall like that because it's being forced here. All right. So in that case then, because the ladder wants to go this way, it's become steeper. So actually A wants to move this way. Friction will oppose that motion. So friction will act this way. So the frictional force on the ground, because of course we've got a rough surface. No friction here though, because it's a smooth wall, it says. Okay. Now, it will help us, right? When you set up these diagrams, it will be a big help if we look at the angles involved. It does say this is angle theta here, where tan theta is 0.8. But what will also help big time, right, is if we're trying to resolve these forces, mainly so that perpendicular to the actual ladder, right? Perpendicular, because we'll take moments, and when we take moments, we need to have the force which is perpendicular to the actual object, the actual rod or ladder. So in this case, right, if we think about it, here's N here, right? I need to resolve this perpendicular to the ladder, 90 degrees, right, the ladder. So if I put, you got a broken arrow here. Now N resolved in this direction. We can work this out, because if you think about it, this is a right angle, isn't it? This is a right angle. So that means this will be 90 minus theta. I'm not going to write it in, but it'll be 90 minus theta. But if that's 90 minus theta, you've got another right angle here, haven't you? Because this line's perpendicular to the ladder. So this is 90 minus theta. This is going to be theta. Okay, so we've sort of seen that sort of thing before. And then resolving along here, this will be n cos theta, won't it? Okay, and we've got the n resolved now perpendicular to the ladder. Okay, this 90 as well. You know, this will be theta, won't it? Because of the parallel lines going on here, right? That's theta. But we need to resolve this 90 newtons perpendicular to the ladder, right? So if that's here, we're going to have 90, that's going to be sine, isn't it? Resolving perpendicular, so 90 sine theta. Okay. Also with P as well, this is really important. So we resolve P perpendicular. So perpendicular for P would be, of course, going along here. Okay. But P is going this way. Now, the way of drawing this diagram might help, because you can see that's a right angle there, yeah? So this angle here would be 90 minus theta here, because it's theta there, it's 90 minus theta, so that means this angle here is theta, okay? So this along here then would be P, along this direction, be cos theta, wouldn't it? Okay, so we've got all the forces necessary. I don't need to resolve this one, right? Perpendicular, I could, okay, and try and work out what the angle is. I don't need to do it, because I'm going to take moments. When I take moments later, I'm going to take moments about A, and I will eliminate eliminate R, rather, get rid of it. So what we do now to start with, we resolve, right? It's important to do this in every question. Resolve horizontally, okay, and vertically. So horizontally, right, now quite simply, you've got friction here, okay, going that way, and you've got the normal reaction going that way, so that's all going to the right, and that will equal then anything going the other way, because they're in equilibrium, and of course you've got P going that way, of course P. Vertically then, okay, you've got R going up, okay, and there's nothing else going up, you've got 90 coming down. That's the only thing coming down, so R equals 90. Equation 1, equation 2. So it says then to show that P equals 120. Now what I'm going to do is I'm going to get these forces now. I'm going to draw a new force diagram, which will help me to actually show the forces resolved perpendicular to it. Because when I take moments, I've got to have the force perpendicular to where I'm taking a moment about. Okay, so that'll be n cos theta there, right? I've also got then through the middle here, I've got 90 sine theta. I'm just using my diagram above, to be honest. And I've got here p cos theta, okay? Now the distances are important. That's 1 there, that's half there, and this is also a half here. And I'm going to take moments now about A. So I'm going to be careful how I do this. So clockwise will be n cos theta times this whole distance, which is 2, of course, yeah, because that's how long the ladder is, equals anti-clockwise p cos theta times a half, right, because that distance is half, plus 90 sine theta times 1. That distance is 1, isn't it? Okay, so you've got all this going on. Now, what might help, right, you might not see this, but because they've given me tan theta here 0.8, it might help here now if I actually divide through by cos theta, okay, because there's cos theta in each term here. If we divide through by cos theta, the cos thetas will cancel, and of course, dividing by cos theta there will give me tan theta. And I'm allowed to do this, right? I'm allowed to divide by cos theta because I know cos theta will equal a value, right? It's not going to equal 0, okay? It's going to equal value. It's not going to equal 0 because, of course, I know tan theta is that. So I've got then 2, if I divide by cos theta there, it'll just become 2n. If I divide by cos theta there, it'll become half p. If I divide by cos theta there, I get 90 tan theta, okay? So this is my third equation, okay? But of course, with 3 then, right, I know with 3, because tan theta is 0.8, I could say, look, 2n equals half p plus 90 times 0.8, okay? And then, you know, I've got something nice, and I can say, look, 2n equals half p plus 72, that works out to be, okay? And I could even times through by maybe 2, so I get 4n equals p plus 144, okay? That's giving me sort of another equation now I can sort of work with, all right? So I've done as best as I can there. But the other thing now I can look at is the friction, right? I can, you know, can look at involving friction here now because I know it's on the point of slipping, okay? On the point of slipping, it says in the question, which means friction is equal to mu r, okay? And we told in the question that friction is actually equal to 0.6, okay? Of course, we know that the reaction is 90. You know that R is 90 because we've seen that up there from 2, yeah? From 2 up there. So you work that out and you get friction to be 54, okay? 54. So I put that now into equation 1. You've got to just play around with the equations here, right? What you've got. We know that's 54 now, don't we? So in 1, 54, okay? So in that one there, friction is 54 plus n equals p, okay? And, you know, maybe I could rewrite this then to be n equals p minus 54. And now what about thinking about now subbing this into there? Okay, that would be good. If we sub that into there, we'll end up then getting something now for p, won't we? Exactly what we want. So we can say now, look, let's just sub this into, sub into 4. Okay, so we'll have 4 lots of p minus 54 equals p plus 144. Okay, so you can multiply that, 4p minus 216 equals p plus 144. So then 3p is equal to, work this out, 360. So therefore p is equal to 120. Okay, don't try and skip too many steps there because you've got to show, understand the process, because they've already given you the answer, haven't they? We've proved that there with what we've got. It says then, what does it say? State one modelling assumption you have made about the ladder in your solution. Well, of course, we always think of a ladder as a rod, right? It hasn't got any dimensions. That's really important, okay? No dimensions involved. So we think of it, we think of the ladder as a rod, which is, of course, going to be rigid as well, yeah? Okay? Solid. It's not going to be moving or anything, okay? So a ladder is, think of it as a rod which is rigid, and we're done.